Okay guys, now that we've gone over some definitions and theorems for section 10.1, we're going to go over some examples of how we use our tangents. So the first question is ST tangent to circle P? So I'm going to take a look at this. There's ST. Well, first of all, if it's tangent, that means it's only going to hit at one point. Well, by the looks of it, so far that looks pretty good. Second of all, if it's tangent, that means that I can draw my line or my radius, okay, from my center to my point of tangency, and if it is indeed tangent, then this should be a right angle. And we'll put a little question mark there because we're not so sure about that. So the question becomes, is how can we either prove or disprove that that's a right angle? Well, the answer is we could use the Pythagorean theorem, because if the Pythagorean theorem's true, then we know we have a right triangle. So take a look at the triangle that we're looking at. 37 is our longest side. It's also our hypotenuse. So I'm going to do 12 squared plus 35 squared. I'm going to put a box because I really don't know right now. And then 37 squared. Going to grab my calculator. Okay, 12 squared plus 35 squared is 1369. Box, 37 squared, also 1369. Those are equal, which means that satisfies the Pythagorean theorem, which means, yes, that's a right angle, which means that's a right triangle. So is it tangent? Yes. It is tangent, which means it only hits ST, that red line, only hits at one dot, and it is perpendicular to the radius. Example 2. In the diagram, point B is a point of tangency. Find the radius R of circle C. Okay, so we know that we're working with a point of tangency, so we know that's a right angle. So if we're looking at the whole triangle, we know we're dealing with a right triangle. Now, we have to figure out what the radius is. We could do a whole bunch of guessing and checking, but if I know that that triangle is a right triangle, I'm just going to revert back to the Pythagorean theorem. So right here, that's my hypotenuse. That's my longest side. Well, think about that for a minute. What is that? The blue part is 50, and then the radius of the circle, but we want the whole thing. So it's your radius plus 50. So we're going to do r squared plus 80 squared equals, in parentheses, r plus 50 squared. Now we have to solve this. R squared plus, I believe that is 6,400, but I'm going to check it. Yep, 6,400 equals r plus 50 squared. Now, if you are thinking in your head, distribute that to, smack yourself with a ruler for me. Thank you very much, because the correct answer is, write it twice, and then you have to FOIL it. Okay, so I'm going to leave the r squared plus 6,400 equals firsts r squared, outers plus 50r, inners plus 50r, lasts plus 2,500. Then we're going to combine like terms, which is going to give us 100r. Then we're going to drop down our 2,500 and our r squared equals, leave this side alone. At this point in time, I'm going to start moving things, trying to get things all to one side of the equation, and we're going to see what happens. So first thing I'm going to do is I'm going to subtract r squared. I'm going to subtract r squared. That one cancels, that one cancels. That's very, very nice. So 6,400 equals 100r plus 2,500. Then I'm going to subtract my 2,500. So 6,400 minus 2,500 is 3,900. equals 100r, and then divide by 100, which is going to get rid of those zeros. So it looks to me like the radius equals 39 feet. And it said find the radius of circle C. So there you go. The radius has to be 39 in order for that to be a right angle. Example 3. RS is tangent to circle C at S, and RT is tangent to circle C at T. Find the value of x. So we have a common external point, and we have two tangents. RS hits at S, RT hits at T. Using our common external tangent theorem, then we know this segment is congruent to this segment. So we can set up 3x plus 4 equals 28. Subtract your 4. 3x equals 24. Divide by 3. X equals 6. And there you go. Example 4. Is DE tangent to circle C? So think about that for a minute. Here's DE. I want to know if it's tangent, meaning does it hit the circle at only one point? Well, remember what has to be true. If that's true, then my radius would also hit that point at a 90-degree angle. Okay, so we can test that with the Pythagorean theorem, but the tricky part here is they gave you this 2. This 2, if you're curious, is only right there. Okay, it wouldn't make sense that this whole thing is 2 when this side over here is 4. How is the longer slanted side less than the bigger side? So the question becomes, well, then what's that? Well, I specifically colored it in red because if the radius of the circle over here is 3, then guess what the radius of the circle over here is? So we know that whole side is 5. So at this point we have a 3, 4, 5 triangle. If you know that that is a common Pythagorean triple, then you've already answered this question. If you don't, then we're going to test it out. 3 squared plus 4 squared compares to 5 squared. 9 plus 16 is 25 compared to 25. Those are in fact equal. So yes, it's a right triangle, and yes, DE is tangent to circle C. Number 5. Points B and D are points of tangency. Find the value or values of x. Okay, so again, if they are points of tangency, this is a common external point. This is a tangent line, AD. This is a tangent line, AB, which means from a common external point, those are going to be congruent. So we're going to have 3x squared plus 2x minus 7 equals 2x plus 5. Okay, so the confusing point of this one is pretty much the algebra and trying to remember how to solve for x. So I'm going to start moving everything to the left, maybe. Let's see what happens. Subtract 2x, subtract 2x. Well, that's convenient. It goes away. So 3x squared minus 7 equals 5. At this point, because my b value just disappeared, I'm thinking we could probably solve this by square roots. So I'm going to add 7. 8, 9, 10, 11, 12. So 3x squared equals 12. Remember, you cannot take a square root until x squared is by itself. So at this point, you have to divide by 3. Please do not skip that step. X squared equals 4. And then we're going to square root that. So x equals 2. And, don't forget, negative 2. Okay. Now, it said answer or answers for x. So the positive one I'm usually okay with. I'm going to check out that negative 2 and see what happens. So if I take that negative 2 and I substitute it in right here, I'm looking at 2 times negative 2 plus 5, I'm looking at 1. Oh, that's valid. That's positive. I can have a distance of 1. Okay, so now we got to check out this one and see if we get the same thing. So 3 times negative 2 squared plus 2 times negative 2. Is that a minus 7? Minus 7. So let's see. 3 times negative 2 squared, that's 12. Minus 4 minus 7 is also 1. Well, those are the same. That answer works. Okay. If x is 2, let's try if x is 2. 2 times 2 plus 5 is 5, 6, 7, 9. Okay, well I can have a distance of 9. And then 3 times 2 squared plus 2 times 2 minus 7. 12, 13, 14, 15, 16 minus 7. Also 9. So this one has 2 values for x. You would have to report both of them to me, because when you substitute them back in, we get positive distances. So both 2 and negative 2 work. Last example using tangents, number 6. Each side of quadrilateral TVWX is tangent to circle Y. Find the perimeter of the quadrilateral. So keep in mind, perimeter, add up all the sides, distance around the outside. Quadrilateral, 4-sided figure. So we're looking at the 4-sided figure. We've got a whole bunch of tangents. So if I'm just looking, let's say, I don't know, right here, there's my external point. There it's tangent. There it's tangent. Now, if I'm coming from an external point, what I'm looking at here is that this guy is congruent to that guy. Okay, which means if I'm coming over here, this guy and that guy are congruent. It's not that the red one is congruent to the blue one. No, no, no. You have to go from the common point on the outside. Okay, so we need to find the perimeter. I'm looking at this top TV. Well, that's 4.5. That's great. Then I'm looking at VW. Well, that's 3.3 and 3.1. That's great. So far, I can just start adding. Then I'm looking at VX. Okay, well, that whole side is 8.3. That's fantastic. And then I've got a 1.2. So it looks to me like I'm only missing one part of this thing, and the part that I'm missing is right there. So that's what I have to figure out. Okay, well that's definitely not the 1.2. Okay, the 1.2 goes somewhere else. But it would match up with this other green one over here. Well, I don't know what that green one is because I know the whole thing is 8.3. So do I know what the blue one is? So look at the blue one. Okay, well if the right side of the blue one is 3.1, then I know that side of the blue one is 3.1. Oh, okay, well now if I know that that side of the blue is 3.1 and the whole thing is 8.3, then I can take 8.3 minus 3.1, which gets me 5.2. Well, if I know that's 5.2, then I know that's 5.2. And then I think I have everything I need to do my perimeter, because this side over here is 5.2, 1.2. This whole side is 4.5. That whole side is a 3.3 and a 3.1. And then this whole side is an 8.3. So I'm going to start adding what I have in circles. 4.5 plus 3.3 plus 3.1 plus 8.3 plus 5.2 plus 1.2 gets me 25.6. It doesn't tell me what the units are, so I'm just going to say units. And that is the perimeter of your quadrilateral.